Hello all, I am Dr. Prabhas Sanjanmal. In today's class, we'll discuss about the Turing machine as transducer or output generator. So what is the meaning of Turing machine as transducer or output generator? This is a type of Turing machine that will generate the output. In the previous classes, we have already discussed about the Turing machine as language recognizer. Turing machine as a language recognizer means, suppose here this is a Turing machine. When we'll pass the input, the Turing machine either accept this means input or reject, means either yes or no. The output like this means Turing machine either recognize or not recognize the input. This is the one type of Turing machines, means we have already discussed about this Turing machine. Okay, but in this class we'll discuss about the Turing machine as transducer or output generator. That means what? Let this one is the Turing machine. When we'll pass the input, this Turing machine will produces the output value. This is called as Turing machine as this one, Turing machine as a transducer or Turing machine as output generator. But this one is called as Turing machine as language recognizer. Okay, this one we have already discussed, means many number of Turing machines, different means for different kinds of languages in the previous classes. Okay, but in this class we will discuss about the Turing machine as output generator, means only this part. Okay, so see the first question. See the first question. What is the first question? Construct a Turing machine that produces 1s complement of given binary number as output. Means 1s complement. What is the meaning of 1s complement? 1s complement means, suppose let a string like 0 0 1 1. Let a string like this. This is my input string. So what is the output of this string? In case of 1s complement, means for 0 input, the output is 1. For 1 input, the output is 0. Means the machine will convert, if it is 0, it will just convert as 1. If the input is 1, it will convert as 0. Okay. So since my input string is 0 0 1 1, so the output of this input string as what? This 1 means 0. This 1 means it will convert as 0. This 0 will convert as 1, and this 0 will convert as 1. Means this is my output. So now we'll construct the Turing machine for this input string, means for 1s complement. Okay, see. So here Q0 is the initial state, means when it will see the input as 0, it will convert 1. When it will see the input as 1, it will convert as 0. That means 0 0 as 1 and move towards right, and 1 as 0 and move towards right. So this is my input string. So here the input string is 0 0 1 1, and I'll just add one blank symbol end of the string. This is my final input string. So it will convert 0 as 1 and 1 as 0. When it will read the blank symbol, see, when it will read the blank symbol, it moves towards right and goes to the final state. See again. Q0 read 0 and write as 1. Q0 read 1, write as 0, move towards right. Q0 read 0 and read 1 and write as 0. Q0 read 1, write as 0 and move towards right. And Q0 read, when Q0 read blank symbol, Q0 read blank symbol goes to the final state, means it will skip or write as blank symbol. So the final output is 1 1 0 0 B, but 1 1 0 0. Okay, but but in the output no need to write the blank symbol B, but in the output no write to B, but here my input was 0 0 1 1. This is the blank symbol. Okay, so this is the final Turing machine for 1s complement. Okay, see the next one we'll see. The second question here, construct a Turing machine that produces 2s complement, of given binary number as output. 2s complement. 2s complement means here for example, I'm just giving example 0 1 1 0 0. This is the blank symbol. 2s complement means just in 2 ways you can find. First, in 2 ways means first find the 1s complement, then add plus 1. In this way you can calculate. This is one method, and another shortcut method is here. When just read from this, means right side, just read from the right side. When you will get 0, just write as 0. When you will get 0, just write as 0. When you will get, means the Turing machine will get the first one. It will just write as 1. After first one, after reading the first one, 1 as 0 and 0 as 1. Okay, this is the method. So 0 1 1 0 0. This is the blank symbol. This is my input string. So now I write. Let us assume that the Turing machine will read. We read from right side. Okay, here Turing machine. Let us assume that the Turing machine will read from RHS part, RHS side or RHS part. See, this is Q0. Q0 read from here. Q0 read the blank symbol. And move towards left. Then goes to Q1 state. B, and L. So see here, the output is, the input is 0, the output 0, the input is 0, the output is 0. That means 0 is just make a self loop. 0 means it's just like a self loop. 0 0, then it move towards left. Okay, 0 0. So it output is 0. When it will get the first one, means this one, 1 as 1, then goes to Q2 state. When it will get the first one, it will give the 1 and move towards left. Okay, then after the first one, after reading the first one, when the Turing machine will read 1 as, this one will be 1 as 0 and 0 as 1, 1 as 0 and 0 as 1. 0 as 1. So here it is just a loop, means 0 1 L and 1 0 L. When the Turing machine will read 0 and it will produces the output as 1. When the Turing machine will read 1, it will produces the output 0. Okay, and let us assume that the Turing machine will read from RHS part, and also one more thing we will assume here, it is a two-side infinite tape Turing machine. It is a two-side infinite tape Turing machine. Means what? See, I just add, this is the blank symbol in the left side also. When Q2 read the blank symbol, when Q2 read the blank symbol move towards left and goes to the final step. Okay, so my input is 0 1 1 0 0, the blank symbol. See, again I'm executing this input. See here, Q0 read the blank symbol. Let us assume that the Turing machine will read from RHS part, and it is a two-side infinite tape line. Two-side infinite tape line. Q0 read B. Q0 read B. Just keep it. Q1 read 0. Output is 0. Q1 read 0. Output is 0. Then Q1 read 1. Output is 1. Then goes to Q2 state. Q2 read 0. Q2 read 1. Q2 read 1. Write as 0. Q2 read 0. Write as 1. When Q2 read blank symbol, just skip and goes to the final state. So this is my output. So in this way, we can construct the Turing machine as transducer or Turing machine as output generator. In this way, we can construct. Okay. So now we'll see some important concepts about transducer. Okay. See, the function performed by Turing machine are classified into two types. The functions performed by Turing machine are classified into two types. Okay, the first one is called total recursive function, and the second one is called partial recursive function. Okay, the function performed by the Turing machine are classified into two types. The first one is called total recursive function. The second one is called as partial recursive function. What is the meaning? See, the first one is called total recursive function. Total recursive function. What is the meaning of total recursive function? A function is said to be total recursive. A function is said to be total recursive if there exists a Turing machine. If there exists a Turing machine for all function values. If there exists a Turing machine for all function values and that holds for all input values. Okay. So function is said to be total recursive if there exists a Turing machine for all function values and halts for all input values. Means it will halt for all input values. For example, say here, what is the example? Additive function. Additive function. Additive function means suppose 1 plus 2 equals to 3. This is a function. Okay, so means f of x plus y equals to f of z, or you can write it is z. Z equal to x plus y. X may be positive value or x, y may be positive value. X, y may be negative value. X may be positive, y may be negative, or x may be negative, y may be positive, but whatever it may be, but the Turing machine will halt for all x values and all y values. This is the This is called total recursive function. Okay, so next point, total recursive function. The total recursive function are similar to recursive language. Are similar to recursive language. Total recursive function nothing but it is called as recursive language. Okay, so this is the clear about this is the important point, means recursive language, and that holds for all input value. This is about total recursive function. So the next one is called as partial recursive function. What is the meaning of partial recursive function? See, the partial recursive function means what? A function is said to be partial recursive. A function is said to be partial recursive if there exists a Turing machine. If there exists a Turing machine for that function, if there exists a Turing machine for that function that holds for some function value, and may not hold for some function values. But total recursive function means hold for all input values. But in case of partial recursive function means it will hold for some input values and hold for it holds for some input values and may not hold for some function values. That means what? The example is here factorial function. Factorial function means, see, for example here, suppose 3 factorial we can find, but -4 factorial it is not possible. It is not possible to find any negative number. We cannot find any factorial of any negative number, but factorial can be find out for positive numbers, but we cannot find factorial for any negative numbers. So that's why, means Turing machine will hold for, in this case Turing machine will hold for positive values, but Turing machine will not hold for negative numbers in case of factorial function. Okay, so this is called as partial recursive function. Okay, the one more important point is here, it is similar to REL. REL means recursive enumerable language. Total recursive function is similar to recursive language, but partial recursive function is similar to REL, means recursive enumerable language. Okay, so this is about Turing machine as transducer and output generator. In the next class, we'll see about some important concepts that are related to the Turing machine. Okay, thanks for watching.